So welcome to the California Avalanche Workshop online. I'm David Reichel, the ED and Professional Observer with the Sierra Avalanche Center. And I have a guest from Oregon here. David, can you please introduce yourself?
Yeah, hi, my name is David Hill. I'm a professor of civil and environmental engineering at Oregon State University. I also teach into the Water Resources Graduate Program. I've been here for about 10 years, and I do all kinds of research on different aspects of the water cycle. So I do things from the oceans, through the rivers, all the way up to the mountains.
And so I think what we're going to mostly focus on is the Community Snow Observations, CSO program that I think you're a huge force behind. And so if you could tell me a little bit about that, how that interacts with your bigger work, why skiers, snowmobilers, backcountry users care.
Sure. So yeah, the Community Snow Observations project is a project that's been going on for about 3.5 years now. And it's a project that's funded by NASA. And what we try to do is that we try to sort of foster this, national and international community of backcountry users who contribute measurements of snow depth to this growing database. And the backcountry community is really critical for this because they're the ones that go the most interesting places in terms of high elevation and in terms of places of really complex terrain. So that's where we're super interested in understanding the distribution and the evolution of snowpack. And so we started this project, and it's a group of researchers, myself and some researchers at the University of Alaska and the University of Washington. And sort of our vision was that we would have backcountry users submitting snow depth data. We use those data points to actually build better models of snowpack. And then those better models of snowpack are of great value to NASA because NASA has a whole bunch of airborne and satellite assets that they use to monitor the snowpack. And they need sort of high resolution information about what's going on the ground. So it's kind of a neat thing, by going out and simply measuring the snow, backcountry users can have their contributions work their way all the way up to satellite missions having to do with snow. So it's a really cool collaboration.
One of the thoughts that sprung into my head while researching your work was, sort of the early snow surveyors. And here in the Sierra, there's this history of people being paid to essentially backcountry ski in the high Sierra, measure the snow, and then communicate that information so that, downstream water users had a guess, I presume, on how much water would be flowing once the melt occurred. And it's interesting to, appreciate how this is a modernization of that work that's been going on for 100 years.
Yeah, that's for sure. And a lot of that stuff that happened back in the sort of the Tahoe area there, some of the instrumentation hasn't even changed. So the people who go out and they actually do snow sampling with these core sampler devices, those things haven't changed in 75 years. So those sort of early pioneers of the snow survey did a great job of coming up with really robust, reliable techniques that are easy to use, and people still use them today.
I definitely feel wimpy when I see the photos of those people in the 20s or 30s with 100-pound packs and like giant pipes and fur coats and axes and stuff skiing in the backcountry. It's like, oh my gosh, I'm such a whiner when I think about my airbag pack weighs a little bit too much or something.
Yeah.
Cool. So, how can Joe Cube backcountry skier, snowmobiler help out?
Well, it's a super easy thing to do. Like when we started thinking about this, about sort of crowdsourcing snow information, there's lots of different things that you can measure when it comes to the snowpack. You can measure the snow depth, of course. You can measure the snow water equivalent. You can make detailed measurements of the vertical structure of the snowpack. And so all of those things are super useful and to different stakeholders, whether it's avalanche forecasters or water resource planners. When our team started thinking about trying to motivate and encourage backcountry users to sort of contribute to snow information, we realized that we had to sort of make it as simple as possible, right? If you're asking people to sort of carry heavy, complicated equipment into the backcountry and make measurements that take a lot of time, people are going to be a little bit less interested because they might primarily be interested in like going out and skiing some great lines. So we intentionally sort of designed our program to be super simple. So the only thing that the CSO project is asking people to do right now is to just make measurements of snow depth, right? And that should be not a heavy lift because everybody should have with them, right, their probes. And probes typically have, well, they're 3 meters long and they typically have centimeter markings, right? So it's this fantastic long ruler that's sitting in everybody's pack. So all that you need to do to contribute to the Community Snow Observations Project is basically have your probe with you, which you should, and then a smartphone, right? So CSO, we have several different mobile applications that can be used to submit data. And the one that seems to get used the most is the Mountain Hub app. And so if you're not familiar with it, Mountain Hub was sort of a startup founded 5-6 years ago. It was acquired by Mammut a couple of years ago. And then our project just acquired the digital platform this summer. So we actually own it now, and we'll be making some good changes to it. And so the Mountain Hub app is something that in the field, your phone, even if you don't have cell service, your phone knows where you are. So you can log a measurement, right? It only takes a minute. And then when you get back into cell service, all of that data gets pushed immediately to our database, and you can see it up on our website the next day. So it's pretty cool. You can go out and collect measurements, and then you can actually come back to our website and you can zoom in and you can see your data and you can see other data points in the area, and you can look at all kinds of statistics about the snowpack in your area.
One of my jobs at the Avalanche Center is as a professional observer. So I dig pits, and I primarily use Snowpilot to record that. And I know that's also one of your platforms that you can draw data from, right?
Yeah, we have a great relationship with Snowpilot, and we're super appreciative of the fact that they are collaborators on this project. And so, yeah, the neat thing about, so Snowpilot, as you know, is a little bit different. It's more of a desktop application where you can log really sophisticated information about the snowpack, the layering and so on and so forth. But a lot of people who use Snowpilot, one of the things that they end up entering is a total snow depth.
Yeah.
And so our website kind of goes in and pulls out just those total depth values. And so we're in, and Snowpilot is probably a third of the data that we get.
What sort of, I don't know, what would you love to see from like backcountry skiers in the Tahoe area? I mean, is there just more obs, people using these technologies and sharing their numbers with you more? And how does that, I don't know, how valuable is like the ground truthing sort of to complement the technological models that exist?
Yeah, so there's a couple of cool things about Tahoe. So the first thing I want to say is that the data that we get from backcountry skiers and snowboarders and et cetera is super valuable. So what we actually do is we run models of really high resolution, like 25-meter spatial resolution models of snowpack in the Tahoe area and in other areas. And we can run these models without CSO observers, and we calibrate the models, we make them as the best that we can, and we get decent results. But then as soon as we get these ground truth data points that come in from backcountry users, those data points get fed into our models, and they basically function as points of assimilation that make the models that much better, because we have this sort of distributed network of observations, which is really spatially extensive. So that ground truthing is really critical, right? And we've been able to show that the improvements that we get in the models with CSO participation are really dramatic, all right? So we would love to encourage people to participate, because when you do that, we're gonna be able to turn out predictions of snowpack, its distribution and evolution that are so much better than what's out there right now. The second thing that's cool about Tahoe is the Tahoe area has a lot of NASA activity going on. All right, so there are a couple of different domains in the Tahoe area which are really important in terms of the SNOWX project. And sort of the SNOWX project is a different NASA effort where they are doing really intensive airborne LiDAR surveys of different areas in the Tahoe area. And so they run these flights probably once or twice a month throughout the winter season. And that team is really excited to get sort of on the ground truth data points of snow depth. And so we work with that team. And so if you participate in CSO and we get data points from backcountry users, those also get fed in to other NASA projects in the Tahoe area.
When you get a on the ground data point, a snow depth measurement, clearly that gives you a point in time for that area, and that helps you improve the model for that area. But are you able, does that sort of improve the models outside of the actual area that's sampled in terms of just increasing the, the predictive or modeling value of those models?
It kind of does. So the way that it works is, so if we run sort of a computer model of the snowpack without assimilation of CSO data points, and at a particular location, if we get a snow water equivalent there of, let's say, a meter, or snow depth, let's talk about snow depth of a meter, but somebody goes out in the field and they measure it to be 2 meters. Well, so what that's telling us is that the model is sort of lagging behind and it's not building enough snow. And so the model will start to basically catch up, and it does so not just at that point, but it also starts to do that at other points in the domain as well. So a local observation kind of has broader effects, if you will, in terms of trying to correct the snowpack processes elsewhere in the domain.
I mean, what are all of the potential data points? I mean, you have LiDAR, like air, radar, people out with their probes measuring the snow. What about, oh my gosh, I guess it's September and I haven't switched over to SnowBrain fully yet, but snow tells and like remote, those sorts of sensors as well.
Yeah, so there's all kinds of information out there, as you mentioned. So, we think about snow measurements as either being sort of what is called an in situ measurement, which means a direct on the ground measurement. And so it's something that you do with a snow sampler or an avalanche probe or a snow telemetry station. So a snow telemetry station measures both the snow depth, but then it also essentially has a large scale and it's weighing the snowpack. So it gives you the snow water equivalent. So those data points, of course, are fantastic. And the Tahoe area has a pretty good collection of snow telemetry stations. So you guys are fortunate in that regard. Another source of snow information is remote sensing. All right, and there's a wide variety of ways that you can do remote sensing. The SnowX project, like I mentioned, they typically use airborne LiDAR. So they're just using lasers that are doing range finding on how far away the snow surface is from the aircraft. You can also do LiDAR measurements of snowpack using UAVs, right? Big drones. So that's another source of information. And then there's also satellite information on snow depth that you can get. So the ICESat-2 satellite is a relatively new satellite mission from NASA. And it functions like the aircraft. So it basically is doing LiDAR, all right, from space, which is pretty cool.
Any conversation points that are critical from your perspective that we haven't hit?
Well, I would really like to encourage people to consider participating. Those of us who like to recreate the backcountry, I think most of us are pretty big consumers of data, right? We look at weather forecasts, we look at snow forecasts, we look at snow tell stations, right? And all of this stuff is fantastic that we have this much publicly available information in this country that we can use as recreationists, and also water managers can use, right? So there's a lot of different stakeholders that have something to gain from information about snow and water. And by participating in CSO, you can play a really big role in kind of making those products that much better. And so if you like to sort of, get a good, reliable forecast of what the snow is going to be like on a day when you're planning a tour, all right, definitely consider contributing just a few minutes of your time to send us some snow depth information.
I mean, this is a example of citizen science, right? And backcountry skiers, you're just discussing participating and helping out science. And, I do think there's a proud history of that. And this is a cool example of using technology to do that. I guess I'm trying to work towards a question here, but from your perspective, I mean, how do you, last year at the California Avalanche Workshop, we had Megan Collins from the Desert Research Institute share another citizen science effort that they do where they're looking at snowflakes and help with that. And I mean, I take your point about it would be, we as backcountry skiers, users of the Avalanche Center, we ask people, check the forecast, consume this information that we're giving you. But it does seem appropriate to also sort of turn that around a little bit and say, participate, send us your observations of avalanches, send us your observation of what's happening in the snowpack, and also send us your observations of snow depth and other things. Yeah, I definitely appreciate your point about the citizen science.
Yeah, and we like to sort of we like to kind of view it as kind of a collaboration or a relationship. It's like we are, on the one hand, we're sort of asking for help, right? We're sort of asking backcountry recreationists to take a few minutes out of their day and collect some data and send it in. But at the same time, we're trying to sort of kind of give something back to the community too. So like I mentioned, we can do things like we can create animations of the snowpack. We can create sort of nowcasts of the snowpack. We can create, if you send us an observation, we can sort of give back to you all kinds of statistical information of what the snowpack is like right at that place where you made observations. So we try to give information back, and we hope that this information sort of helps to educate backcountry users about, hey, what's the snow usually like in this location, and how is it changing, and those kinds of things. So we really would like to we would like this project to be sort of viewed as kind of a collaboration, not just a one-way delivery of information, but sort of a back and forth. And sometimes we get good suggestions emailed into our project from backcountry users about, hey, have you guys thought about trying to make this kind of product available so that it might be useful information for us.
Cool. Maybe wrapping up, like, you guys are on CSO, Community Snow Observations, is on all the usual social media platforms.
Yep.
So people can follow and get information that way. Your website is communitysnowobservations.org or something like that?
It's communitysnowobs.org. Yep. And if you go there, there's a whole bunch of information there in terms of, we have like tutorials on sort of how to get involved and how to use the apps and so on and so forth. We have an interactive page that basically displays all of the data that we've gotten to date. And you could, like I said, you can go in and you can kind of like draw like a circle in a certain area, and you can see the statistics of the snow there and so on. You can also essentially sign up for our email list, and there's just lots of good information there. So that's a great place to start.
Awesome. Okay, well, thank you very much for signing on and talking to us today. And hopefully the air gets better in both of our homes, and
yeah,
we have a nice winter in our future.
Yeah, blue skies will come back, and
awesome.
snow. So.